going to do lesson 46. I don't have a lot of time, so I'm going to see how far I can get in this. So 46a, let's do this. It's a new problem. So it is 3. I'm going to separate these, square root of 7, square root of 3. I'm going to rationalize these, so I'm going to leave a space. And then 5 square root of 3 over the square root of 7 minus the square root of 84. All right, whoops, I didn't leave enough space here. All right, hold on. I'm going to go back and leave enough space. Okay, this is 7. We're going to leave a space to rationalize minus the square root of 84. So we need to rationalize the denominators by taking the numerator and the denominator by whatever's in the denominator, and that will get rid of your square root. So we're going to get 3 square root of 21 over 3 plus 5 square root of 21 over 7. We have to do the tree here, tree it out, so we're going to get 2, 42, 2, 21, 3, and 7. I'm doing it very quickly, I know. The 2's come out, and we're left with the square root of 21. You're going to find that these are usually the same as the denominator, too. I don't know how they made these problems up. Common denominator is 21. We're going to put them over common denominator. This needs a 7, so this is times a 7, so it's going to be 21, square root of 21. This needs a 3, so this gets a 3, so it's going to be 15, square root of 21. And this is over 1, so don't forget to take this one times 21 as well, the common denominator. So take this one times 21, and so we're going to get minus 42, square root of 21. And I'm just going to subtract the coefficients. So 21, or add them, plus 15 minus 42 is going to give us negative 6, square root of 21 over 21, and then you need to reduce this. 3 goes into both of this, so negative 2, square root of 21 over 21. I'm going to check that answer. 46a. Yes, that is the correct answer. Okay, next one, C. C, these are fun. You might not find them fun yet, but square root of 7, and then the square with the square root of 7 underneath it. You're going to replace your radicals with fractional exponents in parentheses like that. This is going to be to the 1/2 power as well, 7 and 7. So then we're going to, these are the same bases, so there's a 1 up here, so we can add these exponents. It's kind of like if you had x squared times x to the 3rd, you would just add your exponents. So this would be 2 halves, and 1/2 would be 7 to the 3 halves, because 1 is the same as 2 over 2, right? And then that's all going to be to the 1/2 power, so we're going to get 7 to the 3/4 power. That's all you do for those. They're not bad, but they're different. All right, number 4 is a word problem. So number 4 is the ratio of elves, fairies to elves. Let's get this right. So this is number 4. Ratio of fairies to elves is 7 to 2. And then it says that the number of fairies was 11 greater than 3 times the number of elves. So we're just going to take this and put it where the F is. And so we're going to get 3e plus 11 over e equals 7 over 2. Cross multiply, we get 6e plus 11 equals 7e. Subtract 6e from both sides. We get e, oops, this should have been 22. Excuse me for that. There we go. So we get 22. So the elves are 22, and if you put 22 in here, you're going to get F equals 77 fairies. So you can always rewatch these since I'm going so quickly. All right, number 8 and is really exactly the same as C. So I'm not going to do that one this time. Number 10 is definitely different. So let's try this one. X cubed, same concept, but with variables. So 4th root of x, y. All right, so we're going to replace the radicals with fractional exponents. This is a 4. The 4 is on the seat. So what's on the bottom goes on the seat. So we're going to get 1/4. We're going to get x cubed, y cubed, and we're going to get xy. Then we're going to multiply the exponents because it's a power to a power now. So it's going to be x to the 3 halves, y to the 3/2, x to the 1/4, y to the 1/4. They're going to be the same. If we add this, let's just find a common denominator. 4, 2, that's going to be 6/4, right? 2, 4, 6. So it's 6/4 and 1/4, so it's x to the 7/4 and y to the 7/4. They're the same exponents on the variables. So that's the main thing for that one. So just with variables, you're going to use the bases, add the exponents on like variables when you multiply. All right, see if I can get these done. I have 9 more minutes. 11 is no one asked for 11 because it's odd. The next one is 17. Solve for the trapped variable. So 17 is ax over b minus c equals k over m. Remember these, you multiply everything by the common denominator, which is bm. So bm for this one, bm for this one, and a bm for this one. The b's cross out, so you get axm minus bcm equals, I can't read my writing anymore. The bm's cross out. So this was actually a k. So we're going to get bk. All right, then you're solving for m, so we're going to take the m out. So we get ax minus bc equals bk. And then you're just going to divide both sides by ak minus bc, divide by ax minus bc. So that's your final answer, what equals m. Okay, told you we're going to go fast. Next one, 20. Solve by factoring. This is a good one. So this is 20. We're going to get negative 40x equals 13x squared plus x cubed. The highest exponent is a 3, so we're going to get 3 solutions for this one. I want to keep my highest variable coefficient, my highest variable positive, so I'm going to move everything to the right. First thing I want to do is start factoring. I'm going to take out an x, so we get x squared plus 13x plus 40. Now I'm going to factor it into binomials, so it's going to be x plus 8, x plus 5. You set each of these factors equal to 0, so you get x equals 0, x plus 8 equals 0, x plus 5 equals 0, and you get your 3 answers then. Your solutions are 0, negative 8, and negative 5. So that's how you solve that. The highest exponent tells you how many solutions you're going to get. Okay, next one. 26, 27, and 29. 26, guys, 27 and 29 are odds. So I don't know what happened on those, so let's just hit 26. 26, find the equation of a line. This will be the last one that I do. So we have negative 2 and 4. You want to find the line that goes through negative 2 and 4 is perpendicular to the line that goes through negative 5, 7, and 4, 2. All right, so if it's going to be perpendicular to this line, you need to find the slope of this line. And the equation for the slope is y2 minus y1 over x2 minus x1. So we're going to get, I can't read my numbers, so we get 2 minus 7 over 4 minus a negative 5, which would be plus 5. So it's going to be negative 5 over 9. That's your slope of this line. We want to find the slope of the line that's perpendicular to that line, so we're going to do the perpendicular slope, which you're going to flip it and make it positive. You change the sign of this. So we're going to take this point and this slope, because we want the slope of the line perpendicular to this line, and we're going to pop it into y equals mx plus b and find b. So the point, this is your x, y, go in where the x and y are. So you get 4 equals 9/5 times negative 2 plus b, and that's going to be negative 18/5. This is going to be 20/5, right? So that's going to be 38/5 when you add negative 18 when you add it. So it'll be positive 18 plus 20 is positive 38/5 equal b. Then finally, you have to write the equation of a line. So the line's in the form y equals mx plus b. Put your m and b in. You leave your x and y in because that stands for the infinite number of points that lie on that line. So it's going to be 9/5 x plus 38/5. And that's your final answer. Let me just check to see. I'm not sure why I have these problems. These must be from a different lesson. You're going to see something weird. Just don't mind it. Let's see. I'm just looking at lesson 46. Yeah, Ashley, you must have done the odd problems because your name for 46 has the odd problems. Okay, so I'm going to close there, and that's it for lesson 46.